Okay, so I'm going to discuss today the quadratic relations. So quadratic relations are equations that can draw out a parabola that looks like this. Okay, and so this whole shape here is a parabola. Now, a parabola has some major points of interest. Okay, one of the most important points on that parabola is called the vertex. It is the point at which the direction actually changes. You see the parabola is falling this way, and then at this point right here at the vertex, it actually begins to rise. So that point is a very, very special point on that parabola. Now there's two other points that are very important, and those 2 points are called the x-intercepts. This is x1 and this is x2. So you've got x1, x2 in the vertex. Now there are three forms of equations that can model this one parabola. One form is called standard form. The other form is called vertex form. And yet another is called intercept or factored form. Okay, so this one parabola can be modeled by any one of these equations, any one of them. So this one is called vertex. Oops, vertex. This one is called standard. And this one is called X-intercept form. Or you know what, I'm just going to call it intercept form. Now, why do I call this one the vertex form? Well, that's because h and k are actually the coordinates of the vertex. So the coordinates of the vertex can be called h and k. What do I call the bottom one? Intercept form. That's because x1 and x2 are the x-intercepts of the parabola. So these are three forms that we are going to look at as we introduce the concepts found in quadratics. Now, let's say I want to plot from a table of values. What I'm going to do now is discuss how to plot vertex form from a table of values. So down below, I'm going to show you how to plot vertex form from a table of values. Okay, so let's say I want to plot y equals x squared. Now, the vertex is one of the most important points on that parabola. So I need to know the coordinates of the vertex. That is a very good starting point because out of the vertex, everything unfolds, okay, and everything is drawn. So I need that vertex. Here's what I do. So step one, I would say, is the following. Ask yourself if there's a bracket around x. If you do not see a bracket, the x-coordinate of the vertex is automatically 0. So I don't see a bracket here around x. So I'm going to safely assume, in vertex form, that the x-coordinate of the vertex is 0. Now, what about the y-coordinate of the vertex? For the y-coordinate, I'm going to look to the right of the exponent too. If I don't see a number there, I'm going to safely assume that that's the y-coordinate, and in this case, it is 0. So the vertex in this very special case is 0, 0. Now, let's say I had y equals x squared plus 2. Well, that just means that the y-coordinate changes to 2 because I still don't have a bracket. The x-coordinate remains intact. What if I had a minus 2? Then the vertex will change to 0, minus 2. What if I didn't have any number on the right, but let's say I did this. What if I had a bracket? X minus 2 squared. Now there's no number on the right side, so my y-coordinate is 0, but what is my x-coordinate of the vertex? The x-coordinate is the number inside the bracket with a flipped sign. So how do you flip the sign on negative 2? It becomes positive 2, so that becomes my x-coordinate. So that is how I determine the vertex just from the equation alone. So that will give me the vertex just based off of the equation alone in vertex form. So all you have to do is determine whether or not there's a bracket. If there isn't, then the x-coordinate is 0. And then you look on the number on the right. In this case, there was no number on the right, so the y-coordinate is also 0. Now, that's step 1. It's getting the vertex. What's step 2? Step 2 is going to be taking that vertex and putting it in the middle of an XY table. So I'm going to create a table, XY, and I'm going to put 0, 0 in the middle of the table. What am I going to do next? I'm going to fill out the X values by going backwards from 0 and forward from 0. And I'm going to do it about twice because I want a total of 5 X values. So how do I go backwards from 0? Well, I'm going to generate negative 1, and I'm also going to generate negative 2. How do I go forward? I will generate 1, and I will generate 2. So now what? What do I do next? Well, if you notice, I've got some X values that don't have Y values beside them. So how do I get those Y values? I'm going to take these X values, and I'm going to plug them in inside brackets. So to fill out that first table, or that first entry in the table, I'm going to plug in negative 2 in a bracket squared, and I'm going to generate a 4. And so I get negative 2, 4 as my first point. I'm going to do the same thing with negative 1, and I'm going to get negative 1 squared. All I'm doing is replacing the x with a bracket and a number. So what is negative 1 squared? It's 1. And so I get 1. Now I'm going to do the same thing with 1 and 2, but guess what? I'm going to generate 1 and 4 again, because the square of 1 is 1, and the square of 2 is 4. Now if you notice here, I've got some symmetry. Okay, 0 is in the middle, and I've got 1, 4, 1, 4 on opposite sides. Okay, you should expect to see that because if I draw a parabola correctly, the parabola is always symmetrical about that middle point, the vertex. So this is what I've generated. I've generated a table. And so what I'm going to do is I'm going to plot this. And this is safely step 3. So I'm going to generate a new page, and I'm going to plot. Okay, I'm going to do my best to plot. X, Y, okay, and this is step 3. Okay, so where are my points? My points are each row of the table. So it's going to be at negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. So if I safely plot those, I get negative 2, 4, 2, 4, negative 1, 1, 1, 1, and I've got the point in the middle. If you notice, look at the shape. I've got a parabola. And there you go. There's your curve. Okay, so we've got our parabola now in that information. And so that is how you plot from vertex form. So let's do another example of an equation together. So let's say plot y equals, 2 x minus 1 squared. Okay, actually, you know what? Make that a negative plus 2. Okay, so I need the vertex of this equation. The x-coordinate of the vertex is inside the bracket. You just flip the sign. The y-coordinate is on the end. And so my vertex is 1, 2. Where does that go? That goes in the middle of the table. And so I have 1, 2 in the middle. I go backwards in the x, 0, negative 1. I go forward in the x, 2, 3. And then to get the missing y values, I plug in those x values on the left. So my equation of interest is right here. So I'm going to take each x value and I'm going to replace x with that value. So let's do the first row. So y equals negative 2, negative 1 minus 1 squared plus 2. Now, what is negative 1 minus 1? Because we have to do BEDMAS now. So negative 1 minus 1 is negative 2. And when you square that, that becomes 4. So this whole thing right here in the bracket with the square becomes 4. So it's going to be basically negative 2 times 4 plus 2. Now what is negative 2 times 4? Well, that's negative 8, and then plus 2 is negative 6. So the y-coordinate beside negative 1 is negative 6. Now due to symmetry, it's going to be the same on the opposite side. Now if I plug in the 0, so I basically go back to my equation and I replace this x with 0. What do I get? I get negative 2, and then 0 minus 1 squared happens to be 1. Negative 2 times 1 plus 2 is 0, and so my two y values that are missing are 0. And so I'm able to generate another plot. So what do I get? Well, my vertex is at 1, 2. Okay? And my other points are at, let's see, 0, 0, 2, 0, negative 1, negative 6, 1, 2, 3, 4, 5, 6, and at 3, negative 6. And so if I connect the dots, guess what? I get a parabola, but it's actually open upside down. Now that's very interesting because usually the parabolas that I've seen so far have been like right side up. So what's going on with this parabola? Why is this one down? The reason why this one is down is because of this negative sign. And we'll discuss this later. So this is basically how you plot a parabola in vertex form from a table. Okay, there are some shortcuts, but for now, let's use a table of values. Just as we were introduced with table of values for a linear relation, we're introducing that here. So all we've done is we've plotted the middle equation using a table of values. So that's essentially it for now. I hope you enjoyed this video. If you did, leave a like, comment, subscribe, and I'll see you in the next one. Peace. Bye.